My name is John Donohue. I'm the Scientific Outreach Manager at the Institute for Quantum Computing at the University of Waterloo. I'm here to talk to you a bit today about graduate programs that are offered through the Institute for Quantum Computing at the University of Waterloo. I myself am a graduate of these programs. I graduated with my PhD in physics with a quantum information specialization in 2016. So I'll talk a bit about the different kind of programs we have for different majors and some of the new programs that we're launching. So first off, where am I coming to you from? I'm coming to you from the city of Waterloo in Ontario. We're a smaller city than Munich. We're about 300,000 people located about an hour outside of Toronto, Ontario. We are traditionally very much a university town. There are two major universities and one major college located in the city of Waterloo. So the student population, I think, during session is something like 10 or 15% of the entire city's population. It's a big chunk. It's a big university town. We've traditionally excelled in engineering and the sciences, and that kind of took another big step in the 90s or so when a graduate of the University of Waterloo founded the company Research in Motion, best known for producing the BlackBerry. So with the success of the BlackBerry, especially in the early days of cell phones or in the early days of smartphones, that led to a large cash influx into the city of Waterloo, which then even further kind of promoted us as a major hub of science and technology, especially in Canada. Now the University of Waterloo is one of the top engineering and science schools nationwide. And one of the passions of Mike Lazaridis, the founder of BlackBerry, was into this quantum science and technology and fundamental physics. And through that kind of influx of interest, we formed what we are calling the Quantum Valley in the city of Waterloo. So throughout Waterloo, we have a wide interest in quantum technologies from the people in the city, as well as multiple institutions that have popped up to support a quantum industry. Institutes like the Institute for Quantum Computing, which I'll talk about in a second, things like the Quantum Nanofabrication Facility, where we can build these quantum devices, things like the Perimeter Institute for Theoretical Physics, a large theoretical physics institute that just studies the foundations of physics and asks kind of the big questions. So we're going to fund those kind of fundamental questions in addition to these more engineering and technology-based questions. So where am I coming to you from? I'm coming to you from the Institute for Quantum Computing at the University of Waterloo. We were founded in 2002 by contributions from the founder of BlackBerry, as well as from the provincial and federal governments of Ontario and Canada. And we've grown since then from a little hallway in the back of the physics department to a full-fledged research institute with 3 buildings and 32 independent research groups. So 32 principal investigators studying all different aspects of quantum mechanics, from people studying the theory of quantum communication, the theory of quantum networks, to people studying software to benchmark quantum computers, to people studying different ways that you can build quantum materials, and they can structure materials layer by layer to get quantum effects on a macro scale, to people studying how to control nitrogen vacancy centers to build new kinds of quantum sensors. So everyone is coming from a different perspective, but we're all kind of unified in the sense that we're using the tools of quantum information science to build new technologies and study new technologies. Through these 32 independent research groups, we have about 300 members at present, so that's including students, that's including permanent research staff. We have a nanofabrication facility on site. So I actually didn't include a slide of the nanofab site. So when you study at the Institute for Quantum Computing, if you are studying, say, electrical engineering or physics, and you're interested in building quantum devices, the nanofab is not hidden away somewhere. It is a large, independent nanofabrication facility located on site. There is a permanent research staff there, there's permanent technical staff there to help maintain all the equipment. But if you're doing research and you are developing these devices, then you are the one in the nanofab actually building the device as well. So you leave with that experience in the nanofabrication facility. Additionally, from these research groups, we've so far had 13 spin-off companies form. Part of that is due to how the University of Waterloo treats IP rights. A lot of universities, if IP is developed At the university, it belongs to the university. At the University of Waterloo, if IP is developed, it belongs to the researchers who developed that IP, and they are then free to form their own spin-off and startup companies based on that IP that was developed. This is our main building now, the Micronophilia Lazaridis Quantum Nanocenter, and if my background works, then it currently looks like I'm inside the staircase right now. If not, I'm in my bedroom, so. So I'd like to talk now about the master's degrees in quantum information. So as Ken said, there are different ways that people talk about a master's degree, and it depends on which country you're in. In Canada, there are two classes of master's degrees. One is very much like you would see in the States. These are often course-based masters. They sometimes lead into a PhD, but are very often terminal degrees. It's your last degree before you go into the workforce. However, what's more common in Canada is that the master's degree almost is like a trial balloon for a PhD. A lot of people enter the master's and then get their master's, leave, go into the workforce. But what a lot more people do, or what a lot of people do, especially in the research-heavy disciplines like physics, is they'll enter a master's program, use it to get familiar with research, figure out if they like their research supervisor, and then take that and continue on into a PhD. Or sometimes what you can do is even get a year into your master's program, realize you're getting along with your supervisor, realize that your supervisor is getting along with you, and then sign up to directly transfer into a PhD program. So most people do not enter directly into a PhD program. If that's what you're interested in, is PhD level research. You would start off with a master's degree and then either complete your master's degree and then go to a PhD program, or transfer from a middle of a master's degree into a PhD program. That being said, if you have a master's degree, it's still a master's degree. You've gotten it. So yeah, there are kind of these two major streams of master's degrees. One of them is research-based. The other one is course-based. So I'll kind of divide and talk about them individually. So to start off, I'll talk about graduate research studies in quantum information. So this is our most long-lasting program. When we started as a research institute, we started based on the labor of graduate students doing research and building these new techniques. At the moment, we have about 190 graduate students. That's 104 PhD students and 85 master's students. Since IQC was founded, almost 300, probably over 300 now, this is a couple months out of date, have graduated from the IQC. So from doing research at the Institute for Quantum Computing, this includes 113 PhD students and 186 master's students. Starting in 2010, we actually introduced the Quantum Information Specialization degree. So that means that you can graduate with a degree, either master's or PhD, that specifically says, I graduated with a degree and I have a specialization in quantum information. It's kind of, right there on the piece of paper that you get. I have a degree, for example, I have a degree in physics, and right beside it, it says physics and quantum information. Since we've introduced that degree, we've had 57 PhD and over 100 master students graduate with that specialization. So notably, I've been saying I haven't really focused on a specific program yet, a specific department yet. This is a collaborative quantum information program. This quantum information specialization is available across 7 different departments at both the PhD and the master's level. It's available in electrical and computer engineering, applied mathematics, pure mathematics, combinatorics and optimization, which is 2 very big words that effectively, in terms of quantum, almost certainly mean cryptography, computer science, chemistry, and physics and astronomy. So University of Waterloo is a little different than some other universities in Canada in that mathematics is its very own faculty. So there's 4 departments within mathematics, 2 within the Faculty of Science, and 1 within engineering. As you can see, in terms of our enrollments, we're about 50% physics students, so 50% of the people who sign up for the quantum information specialization are in physics, but there are major chunks of our student population who are studying electrical computer engineering, computer science, combinatorics and optimization, and applied mathematics. And this is only the ones who are taking that specialization. There are other students working in IQC towards graduate degrees who just didn't sign up for the quantum information specialization, but nonetheless are gaining those very important skills. Another thing to note here is that quantum information is a very interdisciplinary field. Even if you're in physics, for example, you might be interested in projects being worked on by professors who are technically in electrical computer engineering. A good majority of the professors are cross-listed between different departments. For example, the professors who are technically in the electrical computer engineering programs, some of them actually have more students who are studying physics than they have students who are studying electrical and computer engineering. Similarly, some of the theoretical physicists will be hosting mathematics students. Some of the computer scientists will be hosting mathematics students as well. So what I'm kind of getting at here is that if you're interested in a specific research project, don't let your department necessarily dictate which ones you're able to be interested in. I'd recommend looking at all the different research groups you can find, seeing which projects interest you, and then as long as you have some of the relevant skills from your previous degrees, go for it. The program requirements. So I don't want to get in too deep into the program requirements or the costs in this lecture, in this talk, simply because it depends very much on the home department. Depends on which of those 7 home departments you are applying through. Each one has slightly different admission requirements. Each one has slightly different costs, and they are principally set in there. What I can say is common between them is that all of these master's programs are thesis-based. You will need to take 4 courses, but this is not what you're principally doing with your time. Your time is mostly spent on research, in group meetings, in the lab, working on your specific project. The quantum information degree also imposes an additional seminar requirement, so you will have to give 1 seminar to a broader audience of researchers at some point during your degree. That is not true if you don't have that specialization. And you will have to take a couple not extra courses, but some of your courses, instead of having electives, you will have to take some specific quantum information related courses. And as mentioned, there's an option for direct transfer to PhD. As mentioned, the specific requirements change a bit from department to department, but just to give you an idea, for most of them, if you want to start in September, your deadline will be sometime in January to apply. You will have to apply to the program. If you are accepted, it'll be a conditional acceptance on you finding a supervisor willing to host you for a research project. I would recommend trying to contact researchers while you're applying to see if you can find overlap and interest to find a project that you're able to work on there. Once you have been conditionally accepted, we will set up those meetings for you, but it doesn't hurt to kind of get your name out there a bit earlier as well. And in terms of cost, because these are research-based programs, there is a small tuition fee. However, there are research stipends that more than cover that tuition fee. So there's a bit of financial wibbly wobbly to get you there, but at the end of the day, you are not paying to study if you are doing a research program. Your stipend is covering both your tuition and giving you extra cash that you need for costs such as rent. In terms of graduate courses, we offer a few courses regularly. So there are 2 core courses that no matter what degree you're taking, no matter which one of those 7 departments you're taking your quantum information degree with, you will have to take. The first one is quantum information processing. This is kind of an introduction to quantum information through the lens of a mathematician or a computer scientist. This is where you start learning about things like Shor's algorithm, where you start learning about things like super dense coding, those kind of essential quantum algorithms that taught people, got people excited about quantum computing in the first place. So that's the first course you have to take. That one, it's very accessible to engineers and physicists, but definitely if you're computer science and math, you're going to have a bit of an advantage. On the flip side, the other course you have to take is quantum information processing devices. This is where you learn about things like how to build quantum devices with photons, how to build quantum devices with nuclear magnetic resonance spin systems, with superconducting circuits, with trapped ions. This is almost the flip side where you are kind of coming at it from a physicist or a chemist or an electrical engineer's perspective, and the mathematicians and computer scientists are the ones playing a little bit of catch up there. In addition to that, we have courses that are offered regularly on the theory of quantum information processing, quantum algorithms, open quantum systems, nanoelectronics, quantum electronics, and photonics. And as well, throughout time, we've offered over 50 special topics courses, which usually are offered once every 2 to 3 years, or can be requested from professors if there's enough interest from the students. And they span just a wide range of quantum information topics. So I've highlighted a few here. There's a lot more on our website. I just don't have enough room on the slide for all of them. But things like relativistic quantum information, if you're interested in those really fundamental physics problems about quantum information, programming quantum computers, if you're looking for some of those more software-based direct skills, post-quantum cryptography, if you're into the, how do I build a quantum secure network using classical technology, semi-definite programming, if you're in the computer science side. So a wide range of those absolute, needle down special topics courses. And those are open to both PhD and master's students. So that's what I have to say about the research base for now. I'd like to switch gears a bit into talking about a new program that's actually launching starting September 2021. So this is a brand new program that's being designed, and this is a course-based master's in experimental quantum technology. So this will be 8 courses offered over 12 months. This, at the moment, we're offering it only for physicists, so it is a part of the Faculty of Science. It is a master's in physics, and the base eligibility is looking for students who have an undergraduate degree in a science program. So ideally physics, but as Terrell mentioned earlier, when you're applying to graduate schools, there's a lot more room for flexibility. There's an option for an independent project, and while there is no research stipend, unless you take the research project aspect, at least for the first while, there are full scholarships available through the Transformative Quantum Technologies program. We're looking to start with a class of 10 students in September 2021, and those 10 students will have full scholarships available to them. And applications, once again, same as the other ones, application deadline will be somewhere in January. Absolute date, you're gonna have to look on the website to find, and or ask our graduate program coordinator. So in this course-based master's, there are going to be 4 lecture-based courses. The first is quantum mechanics. This is the physics quantum mechanics course, as well as those 2 core courses from before, quantum information processing and quantum information processing devices. You'll also have an opportunity to take a physics or quantum information elective, and either a 5th course, an elective from either physics or quantum information, or the ability to take on an independent research project where you will spend time working with the professors at IQC doing active research and doing an active research project. Not quite as in-depth as a master's thesis, but a chance to do independent research. Additionally, there are going to be 3 brand new lab courses that will be offered through this 1-year master's. The first one will be based on quantum control. So that's where you're going to be working with NMR devices to look at Rabi flipping and other kinds of quantum control schemes. You're going to be looking at nitrogen vacancy centers and how you can control a real nitrogen vacancy center and use it as a quantum sensor. The second part is going to be based on photonic quantum technology. You're going to be working with entangled photon sources and using those to develop quantum key distribution protocols, using those to violate things like Bell's inequality, using those to things like to see non-local quantum local quantum interference, but also non-local quantum interference. You'll be building going through a whole bunch of different experiments, kind of the classic experiments in photonic quantum information processing. And finally, the last lab course will be on low temperature quantum technology and nanofabrication. So there you'll be working with those superconducting circuits. You'll be working with actually designing them in the nanofabrication facility and testing them in dilution refrigerators. So these 3 lab courses are brand new. I'm pretty excited for them. We're designing a lot of the experiments right now, and it's actually a lot of fun. All right, so where can you go with this? So obviously I don't have any alumni statistics for the course-based one because that's a new program that's just being launched, but how have the alumni done from the research-based master's and PhD programs? They've gone to a whole bunch of different places. The majority, partially because of recency bias, a lot of them go to a postdoc right afterwards, so they technically still count as academia, but that does form our largest chunk. Many more have gone into industry, a good number have gone into government. So for example, Gina Basant got her PhD in 2012 and is now an assistant professor at CU Fullerton. Amy Gunther got her PhD in 2018 and is now a scientific advisor at the Defense Research and Development Canada. So, kind of the Defense Department of Canada, so advising them on quantum technologies. So that's, a very government role, very policy-driven role, not exactly the first thing people think about when they think about what you can do with a degree in quantum technologies. Thomas McConkey got his PhD in 2018 and is now a microwave engineer at IBM-Q. We have different people working in different parts of the industry. For example, there's at least 5 IQC graduates who are at Xanadu, the photonic quantum computing startup in Toronto. There are many working at Google and Microsoft. The head of the quantum initiative at IBM is not an IQC graduate student, but is an IQC postdoc, former IQC postdoctoral fellow. So we have those networks to kind of get you into those places. A lot of people at IBM have either come through IQC as a student or as a postdoc at some point. All right, so that's all I have to say about graduate studies for now. I'm happy to take questions, but I just want to quickly plug some things if you're in your third or fourth year of undergraduate studies and you're looking for opportunities in that regard. So, I mean, if you're looking for undergraduate degrees in general, we do have cross-listed introductory courses in quantum information available for undergraduate students, and we have funding to bring in undergraduate students for full-time research terms if you're in a cooperative education program or a program that allows you to have summer research terms. But what I'd really like to point out is our 2-week deep dive summer school, the Undergraduate School on Experimental Quantum Information Processing. It's a 2-week deep dive into quantum technologies. You do a lot of lab things. You get to play with the entangled photon source. You get to play with the NMR machine. You get to play with the trapped ion demo. And this is a school that's open to students of physics, mathematics, chemistry, engineering, and computer science. If you're in any of these programs, you're eligible. We did have to cancel it this year because of COVID, but we are bringing it back for next year. We're hopeful that it's going to be in person, but you know, there's a good chance we'll have to do it online or at a limited scale, but nonetheless, we're hopeful. So we'll kind of we'll keep an eye on, we'll be posting updates on that as news comes in. Travel bursaries are available. It's completely free to all participants. We accept 30 students from all around the world every year. And if you indicate so on your application, we'll try to set you up with a professor to stay for that full 4-month research term. So applications are going to open this week or next week, and they'll be due sometime in January for May and June of 2021. With that, I'd like to thank you for your attention. If you have any technical questions, I recommend getting in contact with Caitlin McDonald. She's our graduate program coordinator. Her email is here. This QR code will take you to more detailed information about the programs and links to learn more about the specific details for your specific department. And follow us on social media if you want to get an update when we actually launch those UseQIP applications. And I'm happy to take any questions. Thanks so much.